idea of the coverage that you've got, right? Because if I've got 3 different scanners, and I'm like, well, I'm going to use them all because they're all going to cover different things, they're going to find different vulnerabilities, and this is magically I had that much money to buy these 3 tools, right? But I just gave a URL and just kind of hoped that it covered everything, right? It's really hard to figure out from a site tree of oh, I got to that file, that file, that file. I'm not really sure that I covered every way to access that file, or necessarily all the different ways that I could have executed those flows. Right? But QA, they've got this functional spec. It's just like, this is all the ways I should be going through this, right? So that's the happy path, right? But security, we care about the unhappy path, right? So it's not just the happy path, but we really need to cover the happy paths too, right? So if we're only covering the unhappy stuff, that's not very helpful either.
So is the kitchen sink attach working? I would postulate the answer is not anymore. It's slowly stopping to be effective. And how many of you guys, who test web apps here? How many of you guys, the first thing you do is read a functional spec? So,
that's another problem.
That's a problem to solve in a different talk. Anyway, so this is one of those really cool visual diagrams that we're going to walk away with, right? You're here, they're here, the bridge is out. We have to build the bridge.
And traditionally we've been talking about security us trying to convert QA, right? And I think there's a little bit of the other way that needs to occur. We need to let QA convert us a little bit in the way that we approach the applications and we actually are using those resources.
And I think what's happening is, as Matt's going to talk about here in a minute, application state, the concept of state in apps is changing.
Yeah, I mean, traditionally people are like, oh, app state, okay, cookies. Not anymore. I mean, I'm going to go back to my Gmail example, right? I mean, I can't just give you a cookie and expect you to hit, oh, you're going to see my Gmail? Okay, well, you have access to it, but you're not going to see the exact email that I was looking at or anything like that. I mean, you need to have, there's a lot of JavaScript state, right? So, while I have server state, I have JavaScript state, which is basically, I clicked on that event, and I caused, some screens to come up, I have a message box. That's a lot more complicated than just, hey, I can make a request, and that's going to be exactly what I see. And this is the problem that we're seeing with the, attack proxies and stuff like that, is they'll just make these requests and kind of hope that the response is the same as what you'd see in the browser.
It's really becoming impossible, as we say here, to decouple the idea of HTTP, like the contents of HTTP, where you are, from the actual client state. That's a key point here, because requests and responses, proxying and capturing and replaying and attacking the sequence of events back and forth between the client and server is just not enough anymore. There needs to be more context here. There's this radical approach, and I put radical in air quotes, but it's really not that radical. It's just nobody's done it this way.
Well, and the fact that we're saying that you can't just point and shoot anymore, right? You're gonna have to do a little bit more work,
and you're
gonna have to have someone else do some more work.
And we have to capture this idea of capturing the user action as HTTP request. Now, sounds really nice, but it's a lot harder than it sounds.
Well, for example, like when we're talking about nonces, right? If I click on this button, but that request, has a nonce or something, I capture that request and I try to reattack it. It's got the nonce in it, so the request is dead essentially after I record it. So what I really want to do is, say that when I click on this button, I want to know the fact that I clicked on this button, not the fact that it caused a request. I want to know as a user, you're like, oh, I clicked the button, and as a scanner, I want to say, oh, when I need to make this request happen, I need to click this button. Not the fact that I just need to audit this request, right? So when I'm attacking the requests, I click the button or whatever, whatever kind of happens. It's just what we're trying to say here is, let's step back. Let's dissociate the need for requests to be associated, or for the need for client action to be strongly associated with requests. And let's just kind of think about it from not the UI level, but let's think about it from a step above just the hard HTTP level.
All right, take a deep breath.
I'm glad someone took a deep breath.
Jeez, lost it, yes. All right, so there's 2 new specs that we're going to start pushing out, and the EFD and E. You guys know what a DFD is, right? Who's going to tell me what DFD is? Really? Come on.
Data flow diagram.
A DFD. Data flow diagram, right? It describes how data flows through the application. That's really cool, but then we're back to proxying and capturing. So what we're going to do is put an EFD, an execution flow diagram. how the application actually executes. So this actually is a radical idea because there's no such thing right now. I haven't actually met a pen tester that has this up on their whiteboard when they start pen testing an app. We're also going to talk about something called an ADM, the application data map. Because when you start testing, you actually need data to get through the application. Now I know as, if we're testing security bugs, right? Oftentimes the key is I don't want to have to use the real data to break in from this step to this step. And that's fine, but that's only going to get you so far, right? We're trying to get better coverage on this whole application attack surface thing.
Yeah, and so stick with us a little bit while we kind of go through like why our background for this stuff, because when we show you later the examples, it's important to kind of understand how we're building all these things, and it'll make a lot more sense to you guys.
So this improved testing process that we're hoping starts to catch on and people start using is step 1, functional spec. Get to know your QA people. It's going to be a good idea. And if you don't have a functional spec that you can work off of, well,
someone's got to know what's going on.
Come talk to me. We'll help you figure that out too. There's application functional mapping first. We're going to go to build the ADM. We're going to map function-based automated testing, and then we're going to manually validate results.
Right. So this is like the summary slide of everything we're talking about. Right. We're saying we need some kind of, not the HTTP request. We need a functional way to go through the application. We need the data to kind of map into that functionality. And ultimately, at the end of the day, I want to be able to automatically use this stuff to attack websites. I don't want to just have to, build this thing and then use it manually. That's boring.
Yeah, because as you'll see later, this is going to be really hard to do by hand. So, some basic concepts, okay? Graphs flows through the application. This is what's going to mean. The nodes in these graphs represent application states. So where the application is.
So when we're talking about states, we're talking about HTTP state, JavaScript state. We're talking about anything that changes what the browser is seeing.
Edges are going to represent different actions. Button click, drag and drop, whatever. Paths between these nodes represent and signify state changes, that something has changed in the application. And then a whole set of this, it's called the flow, right? How the application flows. So execution flow types, there are 3. Right? What is an action? First off, an action is something that causes a change in state. Does that make sense? Good. A human server or browser-based event, right? It can be any of those 3. Whether it's an include, whether it's a button you click or something else that happens, it's going to be one of these things. It's going to be an action. So there's 3 types of actions: a direct, supplemental, and indirect.
So a direct action is something like when you traditionally think about Web 1.0 world. I click a form submit button and it causes an HTTP request. A response comes back, and then I have a new application state. Right? I'm clicking on my add card or add item to cart guy, which then brings me to my shopping cart. This is a completely new response for the browser. It's not just some supplemental request that's being made. This is the Web 1.0 world basically.
Right. So this is a complete refresh of what you're saying.
Yeah. But a supplementary flow, right? This is the Gmail example where I click on the inbox and I click on my compose mail button, and it's not really making new requests to the server, but it's changing all of my HTML content on my page. So there's no actual full context or content refresh, right? It's just staying on the same page. And this is basically the way we're going to map out. How do I correctly find all the JavaScript in how did I execute the JavaScript to get to a certain position?
Okay. And last but not least, we have something called indirect flows.
Yeah. So this is kind of this is kind of complicated, right? But I'm going to try to explain it the best I can and do head shake. I don't understand or nod when you do, right? So there's different ways in which your web page can actually request extra content, right? All of your images in HTML, all that's really extra content. That's really kind of that's not what you meant to actually request, right? But the page says, oh, I need this, so I need to go get it. Or this is all your script includes, this is your site analytics, this is all sorts of stuff like that. And the kind of tricky one is XML HTTP requests, right? How does AJAX fit into this? And AJAX is usually triggered by some kind of user action, right? So I click on compose my email, and then I need to select one of the people I need to send it to, right? There's AJAX kind of going on there, and AJAX is a supplemental request to the indirect actions. Does that make sense, right? Because you have an AJAX request that's made because of an action that you did that's kind of supplementing the action that you created. So that's kind of what we